Okay, welcome to this next video. We're going to be talking today about algebraic factorization. Now, your learning goal for this one is that students make connection between expanding and factorizing algebraic expressions. Okay, and by the end of this one, you will want to be able to fully factorize some simple algebraic expressions. Now, welcome to the world of more HCFs, and maybe you remember from units previous the idea of HCFs being highest common factors. So that this kind of stuff just never really escapes in mathematics, and if you're able to get a handle on it as soon as you can, that's a really excellent thing. Okay, now so remember in previous terms we've had LCMs, which are our lowest common multiple, and we have our HCFs, which are our highest common, be good if I spelt that correctly, I suppose, highest common factor. Okay, so remember those two different things, and lowest common multiples, like if you had 5 and 10, the lowest common multiple between those two would be 20. Okay, and our highest common factors, our highest common factor of two numbers is the largest number that's going to divide into both of them without giving any kind of remainder at all. Okay, now with this factorizing, you'll probably recognize that it's the same thing as we've in the same family of stuff where we just finished with our expanding. So if we had 2x plus 5, remember we expand that out, and the 2 gets multiplied in the x being 2x, the 2 gets multiplied in the 5 being plus 10. The idea is factorizing, so expanding is going this way, okay, but factorizing is going coming back the other way, turning it from a expanded out expression back into something a lot more compact. Now, why do you want to do this? Well, sometimes having a expression in this form is much easier to kind of deal with and do some particular things in algebra with. Okay, right. So let's come down to our key ideas here. So our key ideas: the highest common factor of a set of terms is the largest factor that will divide each term. So there's a couple of ways probably you want to go about doing this. So if I had these highest common factors of 10 and 15, so you can either write the prime decomposition of a number. So for 10x, this term will be 2 times 5 times x. See how I've got that 10's broken up to 2 and 5, and 15 you could do that with, I might write that is 15, sorry, that's 10x, and 15 will be 3 times 5 is 15. Okay, then your highest common factor of those two, you sort of go through circling anything that's common between the two. So we get a 5 and a 5 is common, and that's it. So our highest common factor here is just going to be 5. Okay, right, let's go down a little bit. This one might be a little bit more advanced. So 12a, let's write the prime decomposition for that. That will be 2 times 3. Okay, a times a, and 18b is going to be 2 times 3 times 3 times b. Okay, so let's circle our common factors here. There's a 2 common to both of them, and there's a 3 common to both of them. Okay, so the highest common factor for this one will be 2 times 3, which is 6. Okay, now we have this last one here. I'll give myself a little bit more room. Okay, so we've got 6c squared d and 8cd squared. So 6 times c times c times d. Remember, c squared is c times c. Okay, so that's our 6c squared d, and 8cd squared. Oh, 6. Silly me. That's got. You can prime that out a bit more. So that will be 2 times 3 times c times c times d. 8c squared will be 2 times 2 times 2 times C times D times D. That's our 8CD squared. Okay, right, so our common factors, we've got 2's, we've got a C for each and a D for each. So that means our highest common factor for these two is going to be 2CD. Okay, now any and all of these, that's one way of going about it. You could have done it a different way that you may have seen before, which is simply, for example, if I was doing this 2CD squared one, sorry, this one here, you would first investigate the numbers and investigate the letters separately. Okay, so highest common factor of 6 and 8. So we'll have 6 has 2 times 3 as its one of its factors, and 1 times 6 obviously, and 8 has 1 times 8, 2 times 4, and that's it. Okay, and so our highest common one between those two is 2. Alright, so that's one way to go about with that. And then when you do the letters, you'd have C squared D and CD squared. Well, CD, then expand it out. Probably the best way to do this. C times D times D. Well, you've got a C and a D, a C and a D. Okay. Now the letters are a little bit more difficult to do it up in the table, so you're probably just best off sort of looking at it and doing it by inspection. Okay. With the numbers, either way you can go about it is up to you. So the best probably way to go about it, I think, is to just get used with some of the numbers and performing a prime decomposition just quickly. Okay, the more practice you have with it, the quicker some of those highest common factors are going to come to mind. Okay, so let's have a look at some examples how we're going to do this. Okay, so we factorize an expression by first finding the highest common factor of the terms. So for 14ab and 28a, so the highest common factor of 14 and 28 is in fact 14. Okay, because 14 divided by 14 is 1, 14 divided by 28 is 2. So that will be 14, and between the letters, they've both got an A, so 14A will be our highest common factor. Right, then we place the highest common factor of the terms outside a set of brackets. Okay, so we write ourselves some brackets here. 14A. Then we divide each term by the highest common factor. Okay, so 14a, then our two terms for 14a and 14ab and 28a. Okay, let's give ourselves a bit more room here. Okay, then we're going to divide both of these by the highest common factor. So over 14a and over 14a. Okay. We'll keep working in black, I suppose. So leave the 14 out at the front. 14 divided by 14 is 1. AB divided by A is A. So is B, sorry. So we're just left with B out the front here. Plus 28 over 14 is 2. A over A is 1. So that's all we're left with. Okay, so that's kind of the process that we're going to go through. All right, now we'll have a look just now at a whole bunch of examples. All right, so factorizing the following expressions. Give ourselves a bit more room. I'll pop this out a bit too. Okay, so 3t plus 15. So the highest common factor of 3t and 15 is just simply 3. Okay, so we're going to put 3 out the front of the brackets. Then 3t over 3 plus 15 over 3 gives us 3t plus 5. Okay, boom. It's pretty simple. This is if you find expanding brackets pretty easy, you're probably going to find factorization reasonably easy as well. Okay, so 12 minus 20b here, and so we've got highest common factor of these two ones here is 4. And so that means going to chuck 4 at the front of the brackets. 12 over 4 minus 20b over 4. And so that's 4 with 12 over 4 is 3 minus 20b over 4 is 5b. Okay, so you can see the sign that's the operator in the middle here stays as well. Okay, it's very important. Okay, this next one here is a sort of a particular case that'll be good for us to have a look at. Okay, so we've got negative 8ab minus 16. So the highest common factor of these two isn't just 8, okay, it's actually negative 8, okay, because negative 8 is also the highest common factor of negative 16 as well. So remember, this operator, this minus belongs to the 16. It's important, it's a particular one. So we'll put negative 8 at the front, and then we'll have negative 8 AB over negative 8 minus 16 over 8. Okay, I haven't put the negative in here because it's already sort of there with the minus. Okay, so probably just going to be a little bit careful with that. Okay, right. Wait, no, we don't want to do that. So we'll have negative 8 here, and I'm gonna make this a plus and this a minus. You understand why? Because it's plus negative 16 now. Okay, right. So I've got now negative 8, and we have AB plus 2. Okay. Last two, I'll go through these ones pretty quickly because time's getting away from us quite a bit. Okay, so 18xy plus 40y. So we've got some letters in here now as well. Okay, so our highest common factor here is going to be 2, and so we will have 18xy over 2 minus 40y over 2 gets us, it's 2y, because there's y's in both of them, silly me. So 2y, and then 18 over 2 is 9x, minus 40 over 2 is 20, and then we have it there. Alright, lastly, this one here is a special type of equation. Expression, it's called a quadratic expression because it's got the types of terms it's got x squared and an x, and then an x to a power of 0 we don't see here. And so we can factorize here with all three terms. Okay, now if we look at all three of these, they're all got a common factor of 5. Okay, so what that means is we're going to chuck 5 out the front, and we would have 2x squared plus 3x plus 5 plus 3. What am I doing? 3x in the middle there. 5 divided by 3 is just 5 divided by 5 is just 1 plus 3. Okay, right. Sorry this video's gone so long, but there's sort of a lot of examples there to sort of show you. Okay, please, again, with any of these algebra tools, the best thing you can do is practice, 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 because that will give you a great chance to be able to just allow your brain to change and switch and help to get this stuff right in there for you. Okay, thank you so much for watching, and I'll see you at school.